Hey all, in this video we're going to take a look at polynomial interpolation, right? And so if we have a function, so let's say we have f of x is 1 over x, and we're thinking about it when x is equal to 3. If we wanted to approximate this function, obviously it's easy to plug that value in, but if we wanted to approximate this function, if we had a more complicated function, how might we approximate that function? Oh, a Taylor polynomial. That's a great idea. All right, so we might use a Taylor polynomial. So if we used a Taylor polynomial, and we expanded about x naught equals 1, then remember our Taylor polynomial is Tn of x is f of x naught plus f prime at x naught times x minus 1. Oh, I guess the x naught is 1, so I can make that 1 here. So we're expanding about x naught equals 1. So we have f of 1 plus f prime of 1 times x minus 1 plus second derivative at 1 over 2 factorial times x minus 1 squared. And that would continue up to the nth derivative at 1 over n factorial x minus 1 to the n. And so we could do that. If we did that for this particular function, then if we just use the first term, then when you plug 1 in, you get 1, and that would be it. If you used the first two terms, right, so that your polynomial is x to, sorry, not x, but 1 plus, I guess we would still have, actually we'd have a negative 1 times x minus 1. And so if we plugged a value of 3 in for x, we would get negative 2 as an output. The next term in there would be 1/2. And we'd have, nope, it's not 1/2. It's just 1. X minus 1 squared. And if you plug in a value of 2 for your x values here and here, if you plug in a value of 3, rather, 3 minus 1 gives us 2, 2 squared, so we have 4, plus 1 is 5, minus the 1, minus the 2 is 3. And if we keep doing this, if we get a longer and longer Taylor polynomial, then the distance this is getting away from the actual value of 1/3 is just getting larger and larger and larger. So if we use this to approximate things, in this case, this might not be the best. In fact, it's just going to get worse and worse. Even if we take a longer and longer Taylor polynomial that we feel like should approximate it better, it doesn't. It actually gets worse for us. So we might try to come up with another method to find a polynomial that might approximate that. And this other method that we are going to look at is a Lagrange polynomial. And we will take a look at that in the next video.